What's up, guys? Welcome back to the shop. In today's video I'm going to be working on building a twisting machine because I have quite a few projects in mind that I'm going to be making here in the next few weeks or next few months in the near future, and I don't want to be twisting Damascus by hand. So I'm going to be making a twisting machine. It's going to be based off a twisting machine that Dennis from Tyrell Knife Works made a few months back or a year ago or so. It's going to be roughly about the same thing. I'm going to be using the same main components, and I'm going to be doing a little tweaks so that it fits for my uses and so it can fit in on my anvil, since my anvil is different from his. So there are going to be some minor tweaks and stuff, or I might just set it somewhere else. I'm not sure yet, but for now I want to set it on the anvil because I think that's pretty efficient. So let's get started. All right, guys, so let's talk about our main component. Our main component is going to be this big old right angle drill kit. This guy has a slow revolution and has tons of torque, so that's exactly what we need. I did think about making a hydraulic one before, or making one with a motor and its own like whole setup and stand and place, but there's no real point here because I don't have a lot of room. So I need it to be small and efficient, and while this guy isn't that small, it is in the grand scheme of things. And on top of that, just getting a right angle conversion so that I can slow down an electric motor to speeds that are slow enough to twist steel without shearing it and without splitting it. That piece costs like $400 or $500 plus a motor, then all the base and all the setup and everything. While this by itself costs me $169.99, so $170, and this basically does everything. I just have to mount it and set up a couple small things. So this is the cheaper route to go. I could also buy a twisting machine, but that'll run me a couple grand, so let's not do that. So this is going to be the main component, and we're going to build around this guy. All right, guys, so this is the steel we're going to be using. This is 2x2 1/8 inch wall. This is what I normally use for my canisters. Just cut off about 4 inches, and I cap one side off, and I fill it up with whatever I'm doing, and I cap it off and use it for my canisters. It's going to be the main body for the machine we're building, and this is 2.5 by 2.5. This is 1/4 inch wall. You do not need it to be 1/4 inch wall. I just bought it because that's the only thing I could find around here locally. All that matters is that this can slide in here freely, and you have a little bit of play. That's the most important part. So as long as you got that, doesn't matter how thick it is, preferably 1/8, that's cheaper. This piece cost me, I believe, like 15-16 bucks. This, I do not remember. I had it here in shop for a good while. All this is going to be is we're going to chop it into pieces to use to hold our motor, and on the other side to hold the piece that holds the other end of the bar when it twists, because that needs to be able to slide, because whenever you're twisting the steel, it contracts a little bit, and when it contracts, it needs to be able to slide forward, it needs to be able to move freely and not bind, because if it binds, then it's gonna be a bad day. So let's start on this. All right, guys, so here I have marked our piece of 2.5 by 2.5 that goes inside the larger pipe right there, and I have marked off two 2-inch segments. Each of these, one's going to be holding the end piece that slides back and forth. The other one will be just sitting at the very end or somewhere with some spacers just for it to, sit on here and prop up nice and straight. And this guy is 8 and just a little bit over, pretty much what was left over from the 12-inch. It's slightly over 12 inch, so it's going to be slightly over 8 inches. And the main reason why this is 8 inches is because I need it to be able to sit right on top of the hardy hole, but still be free from the end of the anvil. So to be able to do that, it needs to be at least 8 inches. So I can, so the motor can hang off of here. So that's how I distributed mine. Yours might be different because of where the hardy hole sits. So let's cut these out. Alright guys, so I have everything set up right here. It fits pretty well. I'm gonna mark it off right around here. I have that 2x2 all the way, the square tubing all the way to the end over here. So I have it marked right here, which for me is basically, it's about 21 inches, give or take a few. So 21 inches, I'm gonna cut it off there. If ever comes a time that I need something longer, I can always just pull it out. I know I'm never gonna need something longer unless I'm making like a twist Damascus sword or something. But for now, that's more than plenty. I can always pull it out and drill some holes right here and put some bolts to make sure that everything stays nice and straight. And one of these will be carrying the jig that holds it, the other end of the bar, and one I'm gonna shim up to hold it nice and straight. And if ever I need to get a longer piece, I just put this guy here and take this guy farther out. It's never gonna compress, you know, that much. So we're gonna cut right here. Alright guys, so what I have here is 1/4 inch thick plate, 4x12 is gonna be the little ears that hold on to this part of the drill. Since I don't have a specific measurement or how I'm gonna put it on, I'm just gonna go ahead and cut it in half, tack weld them together, and then I'll just drill one hole through. Same spot, undo them, and weld them. These are probably gonna have to be put at an angle because it's not gonna be wide enough, 4 inches, I don't believe. And because of the way that guy is set up, because of the second horn on the anvil, it needs to be a little bit farther back. So I'm gonna have to do some tweaking around to figure this out, but we'll get it done. Alright guys, so this is where I'm at right here. I have both of the plates mounted on. I just randomly picked a corner and made a hole. I wasn't very specific about it, as long as the holes were the same on both sides. And I have a 1-inch bolt. It's a 1/2 inch bolt on each side, and or 1.5. I don't know. I'll measure it afterwards. That is holding that in place. I have 5 and an 1/8 inch in between, but I can reduce that obviously by taking off washers. And over here I have 2.5 inches side to side. So I'm going to put a 1-inch piece on each side. That'll give me 4.5 inches here, and then I will just adjust on that guy over there. So I'm going to just weld on a little piece of square tubing here that I have, and that should get us closer to our final dimensions. Alright guys, so this is basically the little clamp setup I'm going to be using for the other side of the twisting machine. It took me a while to get it ready, so I forgot to film it because I had a lot of headaches trying to figure out how I was going to do this. But pretty much it's just 3/4 square little square angle welded onto some metal on this clamp so I can adjust the size. And I decided to make this long ways because whenever I spin this to close it, to move it, the whole thing was spinning because this is free floating. So I made it pretty much, it's gonna glide on there, and it's gonna guide it to make sure it doesn't spin. That way it stays nice and true-ish. Doesn't have to be perfect, just has to, you know, close straight. So now I'm gonna be welding this piece of square tubing here to get the right height so that it matches this height, which is 4 inches. It's a 3-inch clamp. Plus, this is an inch square tubing, so I'm gonna weld this, then weld this on top, and we should be good to go. Then I just gotta make my attachments that are gonna hold certain size rod, square rod, and we're good to go. All right, guys, so we are done with the machine. This guy, I just welded some plate steel I had, a 1/4 inch, and just made it a square, 3/4 on the inside. It's pretty simple. And I took a 1/2 inch piece of round stock and I hexed it out a little bit to make sure that the teeth in here would grab on, and we're good to go. Along with that, I've added a foot pedal to it. That way, this is a just touch, turns on, let go, it turns off. And I put a tie down on the trigger just to make sure it's always on, and you know, this is the way it's gonna be used from now on. Makes it easier, makes it more hands-free, and not having to, you know, come down here and pull on the trigger and, you know, all that good stuff. So we're pretty much done. All that's left to do is to test it out. As you can see, it did a very quick work of the steel. Very nice. I didn't twist it all the way, but that was just to test it out. Very good job on the steel. It's a beautiful twist. I didn't do a tight twist, I just did a soft twist, but it's gonna be beautiful in Damascus. Alright guys, so I hope you enjoyed this build. I will be using that guy soon in the near future. I got some twist Damascus and some Turkish twist projects that I'm going to be doing here in the near future, and that's where I'm going to be using that. That's why I built it, because I want to be twisting by hand. So if you like the video, be sure to like the video. Go check out Tyrell Knife Works video. I'll have it in the description down below. If you want to go check out his video for a more in-depth explanation on how and why it is the way it is. So I definitely recommend that video. Go check it out, and I will catch you guys on the next one. Peace.